Alright, so this is problem 7 from chapter 26. The problem reads, in a certain time, light travels 6.2 kilometers in a vacuum. During the same time, light travels only 3.4 kilometers in a liquid. What is the refractive index in a liquid? Alright, so the first thing we needed to do here was determine what it is our time was, because that was the only common denominator that we had in both the cases. So what I did to solve for the time was firstly take the distance the light traveled in the vacuum and divide that by the speed of light, because it says that it was the light actually traveling in the vacuum, and when light is in the vacuum, we know that it travels at its maximum speed, which we know to be 3.0 times 10 to the 8 meters per second. When I did that, I got a value for our time of 2.07 times 10 to the negative 4 seconds for our time. Next, what we had to do was to solve for our velocity in the second part of the equation, or through our liquid media. And to do that, what we had to do was take our distance, or our second distance, which I labeled D2, which was 3.4 kilometers, and divide that by our time to determine our velocity through that media. And we found if you plug in the values here of our second distance and our time, you get a value for a velocity of 1.64 times 10 to the negative 8 meters per second. But after you calculate your velocity, you're not done yet, because you still have to determine your index of refraction using the index of refraction equation, which we know to be N equals C over V, where C is the speed of light, which we used up here, and V is your velocity, which we just calculated. But once you get to this step, you just simply plug and chug. You plug in your value of C, which I said was 3.0 times 10 to the 8 meters per second, and divide that by your velocity, which we found here to be 1.64 times 10 to the 8 meters per second, and you get a value of 1.82 for your index of refraction.